Okay, I thought I'd recorded this, but here we go. We have the problem x over 5 plus y over 7 equals 2, solving for y. It's an equation. As I said, we threw this out and half the class chose to suffer a bit. And the other half kind of cut to the chase and did something very similar to what I did here. And the suffering wasn't too bad because people pretty much got most of or all of the problem right, okay? But we're going to do this way so that when we get to this problem, we'll know what to do. So my common denominator for this whole equation is 7 times 5. Of course, that's 35, but I'm going to write it as 7 times 5 for reasons, well, because you're going to want to imitate these steps. At every step, you want to imitate the steps I did here, but with the symbols. Okay, so I multiply by every term by 7 times 5, okay? And sometimes I write it 7 times 5 over 1 because I'm multiplying by a fraction. I'm going to be sure we understand that. But there we have it, okay? Now, this term can be written as 5 over 5 times 7 times x over 1. Okay, it's pretty clear that the 7 times 5 times x can be 5 times 7 times x and that 5 and all that stuff. We've been over a lot of that, okay? So we can rewrite this way. And of course, the 5 over 5 is going to just give us 1 and the 1 here gives us 1. And we're going to end up with 7x. And now we don't have any denominator in that x term. Well, same thing on this term. Okay, the 7 will match up with the 7. And then we have 5y over 1. And it's clear that this multiplies out the same thing this does. You multiply the numerators, multiply the denominators. It's exactly the same here as it is here. Yep. Except for the order of the 7 and the 5, but we know that we can change that. Okay, so we're going to get 7 over 7 times 5y over 1. That's going to reduce to 1 times 5y over 1, which is just 5y. And over here, we got 7 times 5 times 2. Now, we could multiply that out, we get 70, but we're going to leave it this way because when you do the similar thing over here, you're not going to, excuse me, you're not going to want to multiply them up. Not to the very end. Okay, and you'll see why. And we've already been over examples of this, so you kind of have an idea of why. Anyhow, now we got a few dots here. You want to write out the step because you want to keep reinforcing the steps that get you to your solution. We subtract 7x from both sides, and we end up with 5y equals 7 times 2 minus 7x. That's pretty straightforward. Divide both sides by 5. That's good. Okay. And then 5y over 5, of course, 5 over 5 is 1 times y is just y. And over here, well, we're going to write the 5 over the 5, and then the 7 times 2 over 1. Over here, 7x over 5, there's nothing to do with that, nothing factors over here. So we get y equals 7 times 2 minus 7x over 5, 14 minus 7x over 5, and we're done. Now, it's a little more complicated over here. You're going to want every one of these steps when you solve this thing. So please go ahead and do that. I gotta say, most of you are still choosing to suffer, and you're not really following the steps that I did here. Okay? Now, got a discussion going on back here, so we're gonna let that go from there. Okay. Now, what's the first thing I did over here? I identified my common denominator, which is 7 times 5, right? Over here, I'm going to identify my common denominator. So over here, I could have written my common denominator. I'm going to do that over here. Well, actually, I'm going to put numbers in here. Perfectly happy to do it with the symbols, but I think you're going to like the numbers a little better. Okay, so let's do x plus 4, x plus 7, x minus 6. Okay, so now what's my common denominator? X plus 4 times x minus 6. Okay, so what I do is, now what everybody's seeming to want to do is they want to put everything over common denominator. That can work, but it's much easier just to get rid of your denominators. So I'm going to say, well, this is x plus 4 and x minus 6 over 1 times x over x plus 4. Now that's totally analogous to what I did here. Common denominator over 1 times my first term. Okay. Now, if you look ahead, you see that that x plus 4 is going to divide this x plus 4 and leave you something much simpler. Okay. And with, I think, significantly less chance of an error. Let me get this in one line at my. And that's going to equal x plus 4 times x minus 6 times 2. Now, can you see how everything I've written here is completely analogous to what I've written here? Okay, I've done exactly the same thing. I'll circle the thing that I multiplied by every term so you can see it even more clearly. Now, when I do this, how am I going to rearrange this? I'm going to rearrange this to x plus 4 over x plus 4 multiplied by x times x minus 6 over 1. Okay, got a question? Okay. And over here, I'm going to have x minus 6 over x minus 6 times x plus 4 times x plus 7 over 1. And that's going to equal my right-hand side, which is x plus 4 times x minus 6 times 2. Now, these divide out to 1, leaving me x times x minus 6. These divide out to 1 and the 1 here, leaving me x plus 4 times x plus 7, and my right-hand side isn't affected. Okay. Well, now at this stage, I do lose my connection, okay? Because here we had a y to solve for, and here we've just got this equation. So what do? We use the distributive law and we multiply these things out, right? So we get x squared minus 6x plus x squared plus 11x plus 28 equals 2 times x squared minus 2x minus 24. And then we're going to come on up here and we're going to kind of collect our terms. We've got an x squared here and an x squared here. That's a 2x squared, right? And then we've got a minus 6x and a plus 11x, that's plus 5x. And then we've got plus 28. and we don't have yet. Okay, and that equals 2x squared minus 4x, and then minus 48. Now take a good look at that. Some of you are taking a good hard. Okay, so again, this process, after a while, when you really get used to it, you don't necessarily have to write out every step. You see what's going to happen. You can see here that the x plus 4s are going to match up and leave you this. The x minus 6s are going to match up and leave you this. All this. So x plus 4 is going to match up, which will leave you this. X minus 6s will match up and leave you this. And then this just stays the same until we multiply stuff out. At this stage, we're going to multiply everything out, and we get this equation. Now the question is, how do we solve this equation? So if you write down that equation and solve it and see what you get, then we'll see if you're ready to finish it, okay? I didn't leave myself an abundance of room here, but we can do this, okay? This looks like a quadratic equation. Okay, so what do you do? And in any case, it looks like a polynomial of some kind, right? To solve a polynomial, you want to set it equal to 0 and then see if you can factor it. So you can set each factor equal to 0 and get your solutions. You don't really have another good way of solving a polynomial. Okay? Unless it's quadratic. And of course, all your terms are, the highest power term is squared here, so you know you're going to be able to solve this one. That turns out this ends up even simpler, reduces to a linear equation when you do the sensible thing. But right now, you just look at it and say, okay, it's a polynomial. Going to put everything on the left side. Okay, so I'm going to say, okay, I've got 2x squared plus 5x plus 28 minus the quantity 2x squared minus 4x minus 48 equals 2x squared minus 4x minus 48 minus 2x squared minus 4x minus 48. Okay. Well, this side is 0 because I'm just subtracting this from itself. Okay. Over on this side, I have 2x squared. Well, let me give myself a little more room and write it out in a little more detail than you probably need, but let's just make sure. Okay. So we've got 2x squared here. And I distribute the negative through. Don't want to mix up steps, so we want to be careful. Now, 2x squared minus 2x squared is 0, right? Now, some people like to go ahead and put a little mark through these. And that's one that I don't object to too much. When you start doing it with multiplications and divisions, that's when I want you to keep reinforcing why you can do that, okay? Then later on, when you're open math or whatever, just starts crossing stuff out. You won't cross out the 4 here with the 4 here. Okay, now nobody's going to do that, but I see things almost that bad. Okay, and I see a lot of it. Okay, anyhow, so we have 5x and 4x, that's 9x. 28 and 48 is 76 equals 0. So writing out all the steps. And the steps are pretty obvious at this stage. There we have, okay? So basically all we did was we said, this is an equation involving a polynomial on each side. We want 0 on one side, so we can use the 0 property to solve the thing, or at least to attempt to solve it, okay? So we get everything on one side and we get this. And conveniently, the square canceled out, okay? Subtract it out, whatever. And we ended up with a linear equation. Now, if that hadn't happened, we'd have ended up with a quadratic equation. And then we'd have used a quadratic formula if we couldn't kind of quickly see a way to factor it. Now, I'm going to solve another one and I'm going to skip steps. Okay? And I'm going to solve the same equation. I'm going to put a different number over here. What number do you want over here? 4. Okay. Sorry, Josh, he beat you to it. Okay. Okay. So we got x over x plus 4 plus x plus 7 over x minus 6 equals 3 instead of 2. Okay. Now you're going to go ahead and multiply by x plus 4 x minus 6 times x over x plus 4 plus x plus 4 x minus 6 times x plus 7 over x minus 6 equals 3 times x plus 4 times x minus 6. Okay, make sure I have plenty of room. Okay. Now, here I can say, well, the x plus 4 will divide the x plus 4. And that just leaves me, I'm just going to write it as x times x minus 6. The x minus 6 will divide this x plus minus 6, but you want to do that in your head if you're starting to skip steps. Please don't skip steps the first 10 times you do this, though. Okay. So I can see that's going to happen. At this stage, I go ahead and multiply this out. X squared minus 2x minus 24. Then I multiply these out. I get x squared minus 6x plus x squared plus 11x plus 28 equals 3x squared minus 6x minus 72. Then I subtract this from both sides. Now I can do that. I can match up my squares. If I subtract this from both sides, I'm going to end up with minus 2x squared. Okay. Now, I don't want to cross these out, but I put a little check mark on this stuff. Okay, I put a little check mark above x squared, a little check mark above 3x squared to show myself that I don't have to look at those anymore, that I've already taken care of. Then I've got a minus 6x here and a plus 6x here. Oh, I put a 3 there instead of 4. So, man, I listened to the wrong person, obviously. You were wanting to get rid of your x. Well, you don't really get rid of them. You add 6x to both sides, then your 6x will go away. Okay. And even if you wanted to draw a little line through, I'm not going to do it, but you would see why they go away, and that's probably not a bad idea. Matter of fact, it's such a good idea. I'll go ahead and do that. Okay. Now, I see that was a little too quick. I got an x squared here, right? Okay, so maybe I should have brought this all into one polynomial, which would have made it easier. Okay, and I probably should have done that. Okay, so I'm going to go ahead and do that. And I can very quickly make that adjustment. Well, actually, I can't because I haven't multiplied them out yet. Heck with it. I'm going to write the step, but I'm going to write a couple of dotted, an ellipsis. Okay, so there's a little bit of ellipsis, but we're going to get 2x squared. We're going to get minus 6x and 11x, that's plus 5x, and negative 6. Sorry, we don't have a negative 6, we just have a plus 28. Okay. So you got to expand these and add them. I don't recommend skipping that step. That's why I wrote the 3 dots down. Okay, now my 3x squared and my 2x squared are going to give me negative x squared. My negative 6x and 5x are going to give me 11x. And my negative 72 and 28 are going to give me 100. Okay. I did my arithmetic right. And if it wasn't for the negative sign there, yeah, it's not going to factor. Okay. Yeah. Now I'm going to rewrite this as x squared minus 11x minus 100 equals 0. Just because I'm used to having a positive number in front of x squared, but it's not necessary if you do the quadratic formula correct. Okay, so we do the arithmetic. We end up with this. Square root of 521 is hopeless. Okay. So if it's 529, we'd be in a little better shape, slightly less than 23. And I'm not going to do the solution there. Now, I think you find that that's quicker than putting everything over a common denominator and having the confusion of a denominator there when it can easily be removed, okay? Matter of fact, once you get everything over a common denominator, you just multiply through by that common denominator, everything goes away, okay? So if you write down common denominators past the point where you've got a common denominator, you're writing too much down. And can lead to confusion. You don't need it. Okay. Here's a simple equation. We can solve it without using the quadratic formula. Okay. We could use a quadratic formula, but we don't need it. And the solution's pretty obvious, except that there's something that you're probably going to miss. Okay. No offense. Almost everybody misses it. So statistically, the chances are that most of you are going to miss something. But there's a very good chance some of you won't. No big deal. We'll fix it if you miss it. Okay, now, y'all are with the statistical majority. You said that X was 4, right? That is a solution. It's not the only one. Okay. Now, so can anybody think of another possible solution to this equation, another number that would make it true?
4.
Yeah. Okay, well, okay, you stated that almost instantly. Okay, so you could say that X equals 4, certainly a solution, right? But it's also obvious, if you think about it, that negative 4 is a solution. Okay. And this is the part that almost everybody misses. Again, because it's so obvious that you get 4, everybody gets that. That was easy. I'm done. Nope. Okay. You got to have it -4. Fair enough? Good. Okay. Now, the way we formally solve this is x squared equals 16. So that x equals plus or minus the square root of 16. Okay. Now the square root of 16 is not plus or minus 16, but the solution of the equation x squared equals 16 is plus or minus the square root of 16. Okay. And it's just because of this. There's no more complicated than this, but this is why you write down the plus or minus there. There you got it. Okay. Okay, so let's try this one. Okay, now most people got off on the wrong track here, or at least on a track that's going to make it harder to find a solution. Okay, one thing I can say is informally, x minus 5 is either 9 or -9, right? Because something squared is equal to 81, that something has to either be 9 or -9. Okay. So I could write down so my solutions are 14 and -4. Okay. Much like absolute value equations, which we did earlier. With absolute value equations, I have a lot of trouble getting people to split it into 2 equations. It's very similar here. So that's the informal way. Informally, it's informally. I can't read it, but there it is. Okay, either x minus 5 is 9 or x minus 5 is -9. Now, formally, you have x minus 5 squared equals 81. So a root of x minus 5 squared is plus or minus the square root of 81. So x minus 5 is plus or minus 9. Okay. And that gives us 2 possible equations. X minus 5 is 9 or x minus 5 is -9. So x is 14 or x is -4. Now we could write down the solution set. Oh, boy. A set of numbers, -4 and 14. Okay. Okay, we're running into just a little confusion here, but that's okay. Some people have too many square roots in this thing. That's easy to fix. Okay. Now look, over here we had x minus 5 squared equals 81, right? The automatic next step was the square root of this is plus or minus the square root of that, right? So that you would write x plus 3. Well, let's write out the step. Oh, wait a minute, you're right. You do have too many square roots. Okay. Well, you know what I'm going to do? I'm going to fix this because that certainly isn't what I wanted to write.
Oh man, I was going for it.
Okay, so I wanted 50 there. Okay.
We can do that.
Now, if you had plus or minus the square root of the square root of 50, I kind of made a joke out of that, but it was right. So the joke's on me. Okay. So that's the square plus or minus the square root of 50. Now we'll come back to that one because you can do the square root of the square root of 50. Be the fourth root, but let's not worry about that just yet. Okay. Now, make sense?
25 times. That's it.
So go ahead and finish that up.
25. That times 2. That's the only way to look at it. 5 squared times 2, which would be square root of 50. I don't know, it's more than a square. I'm making things up as I go.
You still got those two square roots.
I do. I'm trying
It's
to.
good. It's good. What you got written down there is really good.
Well,
Okay.
I was gonna change it, but then I realized.
Yeah, you'll see.
Yeah, I don't.
You'll see.
I
I'm
mean,
gonna do it.
I was gonna change it, but then I realized, well, why do that if I've already got it up here? I just didn't feel like scratching it out with 10. So now I'm just trying to subtract the 3 to the other side, but the square root of 5 is square root of 2.
Okay, let's do this.
How come it wouldn't be y cubed? I thought it would be cubed. If it's square root of.
Yeah, because you're
Why
thinking of
9?
what do you square to get 9?
Yeah.
Okay, well, it isn't because it's got to be this.
Because the exponents aren't the same as like the number in front of it. I don't know. Like the.
Yeah, there are rules for how you do the arithmetic of it, but the basis is if you group it like this, it's inescapable. You have to come to the conclusion that it's y to the 4th times the square root of y. And you could check.
Maybe I don't know the square rules anymore. I forgot.
If you square y to the 4th times the square root of y, here we had a question. So confused whether this is recording or not. Okay, again, we inescapably see that y to the ninth is this product. It can be grouped like this, which means we've got 4y squareds and a y. No argument with that. And then the square root distributes essentially. So we get a bunch of y squareds here, square root of y squareds, and leftover square root of y. So it has to be y to the 4th square root of y. Also, if we square this, square of y to the 4th is y to the 8th, because what's y to the 4th? 4 y's, right? Y times y times y times y. And if you write another one, you got 8 of them. Okay, and if you square the square root. Now, if you think y cubed squared, that's just 3y's, which is y to the 6th. Okay, so you'll see a good bit of that. The homework is not particularly difficult once you get the gist of it. Of course, if it turns out that I'm wrong, we'll deal with it.